show you exactly how I do it. I decided I would graph them. So I'm going to graph the first one. I'm just going to plot points. In other words, at 4, we're at minus 4. At x equals 5, we are at minus 3. And at x equals 7, we are at 0. So we have those 3 points. And we know that if I connect those 3 points, the area right in here between the x-axis and that curve is not 0.
Right.
Now, you might say, well, why can't the curve do this? Now it might be 0. In other words, now I could have an equivalent amount of area above the x-axis as below. The problem with the blue is it violates this condition. That says that the first derivative always has to be positive. This would involve a negative first derivative.
Right.
So what it basically means is if the first derivative always has to be positive, then you can't ever come up and come back down. Okay? In other words, you always have to be going up on these curves. And if that is the case, then there's no way that this area can be equal to 0. So that one's out.
Okay.
Number 2, it says that when x is minus 4, or excuse me, when x is 4, again, minus 4. When x is 5, it's minus 2. And when x is 7, it's plus 5. So we have something like this. And what we need is for the areas to be equal. In other words, we need a function whose area from there to there is going to balance out. Hence, the integral will be equal to 0.
Okay.
And notice that that always has a positive slope. So it satisfies the first condition. So that one for sure works. Now, do you ever get problems where you have more than one solution? Is it possible?
No.
Okay, then we probably are done with that problem. The most interesting one is probably D. Let's just take a quick look at answer D. And there we have these points right here. 0, 0, 0. And if you require it to always have a positive slope, well, you can't even do that. That one violates this one right there. If I'm going to go up, I got to come back down. Or if I'm not going to go up, I've got to stay exactly on a straight line, which has a slope of 0, not greater than 0.
Right.
So that one doesn't work. And if you plot these other two, you will find much the same as A, where they doesn't give you anything that can give you equal area above the x-axis as below. And
right.
That's what you have to have. 27. It's been puzzling me. That's the part that I never noticed. This is the answer right here. I kept looking for 10. Here's my rationale. So if the integral of 1 to x of f of t equals this, well, what's the integral from 1 to infinity? Well, I'm just going to plug in infinity for x.
Right.
Now, in the bottom, I can throw away that 21. That's immaterial.
Okay.
What's the square root of 4x squared? 2x. Okay? So, I'm basically 2 times infinity. Well, the infinities, this is a case of what is the limit, and the limit is always the ratio of those coefficients.
Right.
Which is 10. And that's what I originally kept coming up with, and it wasn't on there. And that's because I failed to account for that minus 4 right there. 10 minus 4 is 6. Hold on 1 second here, John. All right, so I think certainly takes care of that page. Now, what else did I want to... We talked about this one already.
Yep.
And I think we talked about both of these. Okay. So those are my latest ones. I didn't get your most recent one.
Huh. Well, I came in from shoveling at about 1:20 and tried to send it.
Might be problematic to send. Yeah, in other words, it may have been because of your internet. Do you have Comcast or CenturyLink, or who do you use?
I have CenturyLink. My phone still says sending 1 of 1.
Okay. If it still says sending, then it hasn't sent, although it just came in.
Oh, there we go.
2 seconds ago, it just came in.
I don't know what was happening with it, but...
Okay. Cool. Back to normal problems.
Yeah. I figured I didn't get any new material today because I didn't have school. So I want to work on the problems for the AP test that I need to know I can get right, so I can get as many of the easy problems right.
I do have a new student tomorrow, day after tomorrow, who wants an understanding of Taylor polynomials. So I'm going to have to refresh up on Taylor polynomials, and if I feel like I get to a point where I can help you on them, I will. I know you mentioned that's probably the hardest thing you've had so far.
Yeah.
Okay. Well, I understood it at one point. It's been a while, but I'll check up on it again. And there will be a question or two on your AP test regarding those. So let's look at number 12. What rule are we going to use here?
Are we using 2 rules?
Well, here's the rules you got in differentiation. You got the power, you got the product, you got the quotient, and you got the chain. And usually you have to use 2, and we will here eventually have to use the chain rule. You almost always have to use the chain rule. But the question is, are we going to use the quotient rule or the product?
The quotient rule.
Now, the quotient rule is the hardest one to remember. Do you remember it?
The derivative, so low d high minus high d low over the square of what's below.
If you remember it that way, that's perfect. I remember it. You start with the bottom, the derivative of the bottom, and you end with the bottom squared. That's all I need to remember.
Okay.
Now, it's worth mentioning to you that I don't have to use the quotient rule here. I can use the product rule. I can write this thing like this. Now, the product rule is a little simpler, don't you agree? So you're going to get the same answer regardless. But let's just do it by the product rule. So how am I going to do the product rule here?
Well, we're going to bring down the -1 first.
Okay, well, first of all, are you doing, in other words, whenever I do the product rule with people, I never know which way they're doing it. In other words, if y equals u times v, then y prime, I recommend always starting with u, and then v prime, plus the opposite. And the reason I say always start with u is because people spend a lot of mental energy trying to figure out which they can differentiate and which they want to start with. So just always start with u.
Okay.
Okay? And I think it'll be easier for you. You don't have to do it that way, but when we're doing it online, I never know where the person is starting. I don't know if they're starting on this one or this one, and it becomes difficult for me to follow along.
Okay.
So just satisfy me and start with u as your first term.
So you would be 3x and then times.
Okay, now v prime.
So it'd be 3x times -1 times x squared plus 1.
To what power?
So you're adding, no, you're
Subtracting 1.
subtracting. -1 minus 1 plus -2.
Okay. And then what else do we have to multiply that by? In other words, here's where we have to apply the chain rule. In other words, what's the inside?
Oh, times 2x.
Right. That's the first part of it. That's that part. Now it's the second part.
So then plus 3 times x squared plus 1 to the -1.
Uh-huh. And there's no chain rule to apply there because we didn't differentiate v.
Right.
Okay. So personally, I think that's the easier way. And of course, there's some consolidation you can do to that answer.
Right.
You multiply 2x times 3x to get 6x squared. Put that negative sign in front of all of it. So I think it comes like something like this, minus 6x squared all over x squared plus 1 squared. That's the first part. Plus 3 all over x squared plus 1. There you go. And I believe, well, I know you have to get the same answer, whether you use the product or the quotient.
Right.
The thing is that the quotient can frequently be quite difficult to simplify. The algebra can almost be harder than any algebra you've ever done before.
Right.
Plus when I was refreshing and I had a hard time remembering the quotient rule, I just used the product rule all the time. But not that I'm suggesting you do that.
Okay.
But it's an option, and it's worth knowing that you can do it that way. Now, we won't spend the time to do that problem using the quotient rule. Let's look at the next one. Do the same thing, can't we?
Yeah.
So write it for, which way would you rather do it? Shall we do it using the quotient rule this time?
Sure. Let's just do it to do both.
So we have to practice it both. Because there might end up being some that are hard to do both ways. And okay. So we start with what?
Low, D, high. So
How to translate to, I'm not.
D
high. Is that the derivative at the bottom?
no. So x plus 1 to the 5th times 8.
Okay, I got you. So
And then,
that is the bottom times the derivative of the top.
right,
And is it plus or minus?
minus 8x minus 1 times 5, 5 times x plus 1. So 5x plus 5.
To the fourth.
To the fourth. Yeah.
Right? And then we would have to apply the chain rule on that part, but the derivative of the inside is 1. So we can kind of ignore it.
Right.
Okay? And all of that's over...
All that is over x plus 1 to the 5th squared.
Okay. Now, you can kind of see where the simplification problem comes in.
Right.
What can I can at least take 4 of these things out of top and bottom, right?
Right.
And that's going to leave, after the minus sign, I'll do that side first. That'll leave 5 times 8x minus 1. And over here, we'll have an x plus 1 times an 8. And down below, we'll have x plus 1 to the 6th. And now we can see we can simplify that, as we have 8x plus 8 minus 40x plus 5, which is minus 32x plus 13 on top, x plus 1 to the 6th on the bottom.
Okay.
I think that's the answer. Problem with these is there's so many steps, and so if you make one mistake, you're screwed. One math error, you know what I mean?
Yeah.
And then figuring out whether you did or not is even harder. This is where multiple choice would kind of be nice, because at least we'd know whether that was right or wrong if it was an answer or not.
Mm-hmm.
All right, let's go on. Let's try to do this second derivative here. So let's start with dy dx. What is that going to be?
Well, we could use the product rule again.
Whichever you want. Product rule actually is going to work pretty good because there's nothing inside, so the chain rule won't even be needed.
Right, so it's going to be x plus 3 times x minus 1 to the negative 1.
Okay, so if I use the product rule, we're always going to start with x plus 3, just to get us going.
Right.
Times
X plus,
minus, go ahead.
so times minus x minus 1 to the negative 2.
Yeah, I put that negative sign in front of the first term,
Okay.
which is fine. Okay, and this is plus because we're using the product rule.
Right. Plus x minus 1 to the negative 1 times, well, just times 1, so.
Correct. So that is dy dx. Now, let's see if it helps to simplify that. That gives us this. I suppose I could do this, put an x minus 1 up there, and then make this squared.
Right.
And that's going to be useful because now I can simplify the top into 2x plus 2. over x minus 1 squared. Gee, you could almost, if only that after factoring out a 2 you were left with x minus 1, you could really whittle it down. But
Yeah.
you can't. That's y prime. Now, y double prime is taking the derivative of that.
So we'll do product rule again. So then 2x plus 2 times.
Hold on, let me erase some of this and let's do it. Start from the top. So I've got y prime. I'm going to try to write a little smaller here. Now we're going to do it by the product rule, so I'm going to write it like this. Okay, so y double prime.
2x plus 2 times negative 2.
I'll write that negative 2 like that, just because I don't have enough room on the other end. But
okay. Negative 2 times x minus 1 to the negative 3
plus
x minus 1 to the negative 2 times 2.
And again, we can do some sophisticated algebra, not really that sophisticated, basically finding a common denominator. Common denominator is going to be x minus 1 cubed. So I'm going to write this first term. I'm going to distribute that negative 2, so I have minus 4x minus 4 all over x minus 1 cubed. That's going to be my common denominator. And I already have an x, excuse me, so easy to make a mistake. X minus 1 squared, and up top I have a 2. And so if I want to make this x minus 1 cubed, I have to put an x minus 1 up there, and now I can make that cube. You with me?
Yep.
Now my final answer is going to be minus 2x in total. Let's see, I got a minus 2 and a minus 4, so that's minus 6. And down below I got x minus 1 cubed. Now, I suppose the question always is, do you take the time to factor the top? The answer is not if it doesn't benefit you. If by factoring the top I was left with an x minus 1, I definitely would do so. But I'm not going to be. I'm going to be left with an x plus 3 if I factor out a negative 2. In other words, I won't really advance the solution at all. And so that would be my final answer. I don't do the factoring unless it serves a purpose.
Okay.
Okay? All right. We got 5 minutes. You want to pick? You want to just keep going in order?
Let's just go in order, because I was going to pick 15 anyways.
Okay. Is this y double prime on 15?
Yes.
Okay. So let's start here. Let's find out what y prime is.
I don't know what the derivative of cosecant x is.
Okay, let's back up a minute then. Let me give you some tips on these. On the left is the function, on the right is its derivative. I'm going to write it a little differently here. I'm going to start with these three. Let's see, sine, cosine, tangent, secant. That's the one I want. Remember secant?
Yeah.
What is it?
Oh, wait.
That's what it is.
Okay.
Okay? Now, if you can remember those three, the others can be figured out. If I take the co-function of sine, that's cosine, it's going to be the negative of the co-function of this. Well, the co-function of cosine is sine. Same thing for cotangent. First of all the co-functions start with a negative sign.
Okay.
And it's going to be the co-function of secant squared. So it's got to be cosecant squared of x. And finally, you take the co-function of secant, which is cosecant. It's got to start with a negative sign. So what is that?
Negative cosecant x times cotangent x.
Yeah. This way, you only have to remember those three.
Okay.
And then the other three follow based on co-functions.
Right.
You know what the co-function means? It's 90 degrees minus. In other words, the sine of x is always equal to the cosine of 90 degrees minus x. That makes them co-functions.
Right.
And obviously, the title, you just take the trig function and put co in front of it, and you have its co-function.
Right.
All right. So we got our, let's finish this one if you want.
So would we use, could we put cosecant to the negative 2 power?
No. This is 1/2 cosecant of x. It's not even the cosecant of x over 2. It's 1/2, in other words, it's the cosecant of x divided by 2. So another way I can write it, and maybe it makes it a little more understandable, is put that 1/2 out there.
Okay.
Okay? So our answer is going to start with 1/2.
Right.
But it's also going to start with what sign? Plus or minus?
Minus.
Okay, so let's put that there out there also.
So,
And then what's the derivative of cosecant x?
Secant, or no, secant x tangent x.
It's the cofunctions of those. So instead of
so cosecant x
secant x tangent x is the derivative of the secant function. So the derivative of the cosecant function must be the cofunctions of those first two. Well, the cofunction of secant is cosecant, and the cofunction of tangent is cotangent.
Okay.
Okay? So that's the first derivative. Second derivative. Treat this as u, treat this as v.
Okay. So it's going to be negative 1/2 cosecant x cotangent x.
Well, now hold on. This is u. So we're writing u and then what's v prime. So we need the derivative of cotangent x.
So the derivative of cotangent x is cosecant x squared.
Cosecant squared x.
Cosecant squared x.
And there is a difference. And we know it's negative. all the derivatives of the cofunctions begin with a negative sign, so that turns that first negative into a positive.
Okay.
Hold on, let me rewrite this a little bit. Do you realize what the difference between cosecant squared of x and cosecant of x squared is?
Yeah, cosecant x squared is like part of, if you can write parentheses around the cosecant x squared.
Right, and you square the x first, and then you take the cosecant of that.
Yeah.
Whereas this is the cosecant of x times the cosecant of x.
Right.
Okay. So we just did uv, now we got to do vu. Or we just did uv prime, and now we got to do vu prime.
So plus cotangent x.
The easy part, yeah.
Times -1/2 cosecant x cotangent x.
Okay. And the negative, it's actually going to
change positive.
So our very leading term in all cases is now going to be positive. Okay.
Right.
So I've got 1/2 cosecant x cotangent x. Whoops, ran out of room. Which happens a lot. I don't know why I haven't forced myself to start starting on the far left. Can't do it. And that 1/2 can be put in front of here, taken out of there. You could even put it in front of both terms, factor. There might even be some stuff you could factor out. Right offhand, it looks like we could factor out a... Nope. Nope. No, hold on. Cosecant x, yeah. You can factor out 1 cosecant x.
Right.
I don't know. Again, I don't see the advantage of doing it if I can't simplify it. It's all determined by whether you can simplify it or not.
Okay.
All right. So that's the end of the half hour. Let me just have a quick, brief look at these. That's a simple product rule.
Yeah, I can do that one.
This is going to be an integral.
Why?
Well, because, oh, excuse me, my mistake. No, it's not. It's not.
Okay.
However, it's going to be a double chain rule.
Right.
In other words, your first u is going to be sine of 4x, and your second u, or we'll call it v, is going to be 4x. So you're going to have to apply the chain rule twice. It's a subtle distinction between finding the derivative of that and finding the derivative of that. In this case, u is sine x. In this case, u is x squared.
Okay.
And in this case, you got both. So it's definitely a double chain rule application, as is this one.
Okay.
18 also. John, I will let you go to do more snow shoveling, I imagine. Jeez, 18 inches. You're going to be at it all day.
Yeah, it's going to be fun. I'll probably be clearing snow tomorrow night as well.
Well, it replaces the workout that you're probably missing on the baseball team.
Probably, yeah.
You guys have an indoor facility?
No, we just practice in the basketball gym.
Okay. Have a good one. Talk to you later.
All right. Thank you.
Bye-bye.